I'm going to write the equation for Newton's law of cooling just so that we have it written down to reference. So we have T minus T sub S is equal to T sub 0 minus T sub S times e to the negative KT. And T sub 0 is the temperature at time T is equal to 0. All right, so we're gonna do one that deals with like cooling down some silver, and then the one that I'll give you to do is cooling soup, but the process will be the same for that. So number 32, the temperature of, and I guess it's ingot, I don't really know, INGOT, of silver. Yeah, that thing, sure. Is 60 degrees Celsius above room temperature right now. And then it says 20 minutes ago. It was 70 degrees Celsius above room temperature. How far above room temperature will the silver be? And then we're going to look at it for different time increments. So the first one is going to be 15 minutes from now. All right, so we know that at the present time, the temperature is 60 degrees above room temperature. So we're just going to treat it as like 60. So T sub S is going to be 60 degrees Celsius. Well, more or less. And then T sub 0, we might end up kind of calling that something different in a minute, but that's going to be 70 degrees Celsius, which was 20 minutes before. So that basically means when time is 20 seconds, it is cooled to this temperature here. So 15 minutes from now, so I've got T minus T sub S is equal to T sub 0 minus T sub S e to the minus KT, and I'll be plugging stuff in, but that's my initial formula. So I know that T minus T sub S is equal to 60, because that's going to be the what the temperature is right now at this present moment. Then the T sub 0 minus T sub S is going to be 70. Because that would have been the initial value. So then I'm going to replace that stuff over here. So I'm going to have 60 is equal to 70 times e to the minus k times, we know this happened after 20 minutes because this said it was 20 minutes ago, it was 70 and now it's 60, so t is going to be equal to 20. Write that there. So I'm initially solving for k so that then I can go back and look at like 15 minutes from now what's happening. So I would end up with e to the minus k times 20 is equal to 6 over 7 because the zeros are going to cancel. So 60 divided by 70. So then make my L. So ln of 6 over 7 is equal to negative 20 times k. So then the ln of 6 over 7 divided by negative 20 is equal to k. And I'll type that in really fast. And so this ends up being 0.0077 . So now this is kind of all just the setup for the rest of it. So now our new T sub 0 minus T sub S has to be 60 because that's our new initial. Basically, we're getting a new initial. So now T sub 0 minus T sub S has to be 60. And so then we're solving for the other side now. So T minus T sub S is equal to 60 times e to the minus 0.0077, and then 15 minutes is what we're doing. So then that's going to be since I already had that number saved in my calculator, I went ahead and used that. Just so I would have it. And times 15. And when I'm done with that, that gives me that's equal to 53.45 degrees Celsius above room temperature. Um, 15 minutes from now. So now I do the same thing I just did here. So basically everything to this point is all just like the setup of it that I needed to be able to get to that point. So I'm going to use all that stuff. So basically the only real stuff of actually part A is what's written here in green. This is really the answer to part A. The rest of it was kind of like prelim work to get there. So part B now wants us to do it for 2 hours from now. Now, that's not from the 15 minutes having passed. That's from the now that was given to us originally, that it was at 60 degrees. So we still have that, what do we need to pay attention to now in terms of this? The units. So this is now hours, but we were in minutes. So since I have the number, this 0.0077 was done according to minutes, I need to switch this to minutes. So how many minutes are 2 hours? 120 minutes. So I have the same T0 minus TS is still 60. So the only difference in the one that I just did for part A is that it's now instead of 15 minutes, it's now 120 minutes. So T minus TS is equal to 60 times e to the negative 0.0077 times 120. And that gives me 23.82 degrees Celsius above room temperature 2 hours from now. And so we could do that for any increment of time and figure out what the temperature is going to be at that time. The next part says, so part C, a little different. Instead of finding what the temperature will be at a certain time, it says, when will the silver be 10 degrees Celsius above room temperature? So now, I don't have the time. That's what I'm trying to find, is how many minutes is it going to take to get there, because I still need to be in minutes. If you started in hours, we would have seen in hours. But so when will the silver be 10 degrees Celsius above room temperature? So we are going to our T0 minus TS is going to stay 60. But now our T minus TS is going to be 10 degrees. And I'm solving for time. So we would have 10 is equal to 60 times e to the minus 0.0077 raised, or t. So then that's going to be e to the negative 0.0077 t is equal to 10 over 60, or 1/6. Then I can use ln. So ln of 1/6 is equal to negative 0.0077 times t. And so that's going to be 232.6, 0.7 because of the rounding, minutes. And if you wanted to convert it to hours, you could, but considering everything else pretty much was done in minutes, I would just leave it in minutes. The book gives the answer both ways, so either way is fine. If it was a short answer question on the AP exam, it might be beneficial to write it as minutes and hours, but I don't think they're going to really care either way, as long as you have it, approximately. So. So the only additional question, and it's the same same kind of question. It's not exactly the same, but it is number 31 would be a good one to look at, for that. But if you can do those two kinds, you should be fine.